Hello and welcome to my channel. In this video I'm going to go through changing the minimax to alpha beta. Now what you have to bear in mind is alpha beta is not an approximation of minimax. Both of them give exactly the same result. It's just more accurate. It's just a better algorithm. Now a good analogy to make you understand the difference between the two is, imagine that you know there's someone who you know and they absolutely hate your guts, and they wouldn't, any opportunity they get, they'll poke you in the eye, and they are your biggest enemy. Now imagine that there was some court case or something happened, and the judgment was they're gonna put all their belongings in 5 bags, and the rule is you pick a bag and they've got to give you one thing out of that bag. Okay? Now this is how the Minimax algorithm works. The Minimax algorithm would go and it would look at the first bag, and it would look for what it wants to do. It knows that the person is their enemy. You know that the person is your enemy, so you know that they're going to give you the cheapest thing in that bag. They're not going to help you one bit. So what you have to do is find the cheapest thing in each bag and take the best cheapest thing. Take the bag with the best cheapest thing in it. Okay? So what Minimax will do, in the Minimax algorithm, it will go to the first bag and it will take the first item out, and the first item will be £100. And then it will carry on looking through the bag and it will compare every single item, and then at the end of it comparing, it would say £100 is the least. So £100 is the worst thing in this bag. So then you would say, at least I've got £100. And then what it would do next is it will go to the next bag, and the next bag would contain, the first thing it would take out is £1. And even though it's taken out £1 out of that bag, it will carry on the same algorithm. It will look through every single thing in that bag and it will compare every single one, and then it will say £1 is the best worst thing in this bag. So therefore it can't beat £100, so it says I'm not taking that bag. Then it will go to the third bag. The first thing it will take out is £1 million diamond. Okay? That's the first thing. The second thing would be £99. Okay? And then after that, it will carry on searching the bags to find the minimum value thing. And in the end, the minimum value will be £99. So we'd say, this person is my enemy. They're not going to give me the diamond, so that bag is no good to me. So they still say the first bag with £100 is the best one. And that's how that algorithm would work. They'd go through each bag and find the best worst thing. And at the end of looking at all the bags, it would say £100 is the best worst thing. So that's what it will take, because that person is my enemy. And they're going to always give me the worst possible thing they can give me. Okay? So that's how Minimax works. Okay? Now alpha beta, this is the difference between two of them. This alpha beta works. The first bag will do exactly the same thing as Minimax. It will take the £100 first. It will look at every single thing. Then it will say £100 is the best worst thing. So it will say, at least I've got £100. It will then go to the second bag. The first thing it will take out is the pound, just like the other one. And then it will say, this person is my enemy. This bag contains, the bag contains a pound. I've already got £100. It's a waste of time looking at anything else in that bag because they're going to give me that pound, because the pound is less than the £100 that I've already got. So it's a complete waste of time me looking at anything else. So I just throw that bag away. I'll go to the next bag. I'll take out £99. I mean, I'll take out £1 million. I'll take out the £1 million diamond. The next thing I'll take out is the £99. And then it's the exact same thing. It's a complete waste of time looking at anything else in that bag, because that person is my enemy, and they will not give me the diamond. So what it is, that's how Minimax will work. It will cut down the tree. Now, some of these operations in the tree, like for instance here, it's getting all the moves. These are quite slow, and here it's making moves and it's taking back moves and it's evaluating the ball position, seeing if there's four in a line. In fact, it's not doing that in a loop, but still it's doing it quite often. If we go for 1 million positions, right? When it says it's looked at 1 million positions, remember it counts here, so that's 1. So when it does 1 million positions, how much times has all of these done 1 million times? And if alpha win, that's not going to win 1 million times, but something like this, legal move, that's going to run at least 10 times. Okay, and look at legal move, look what it contains. So if an algorithm can cut out any other tree, then it's going to be much faster. Okay. So what I'm going to show you again is a min-max diagram. I'm not going to go too deep into it. I just want to show you that how the computer, how it goes down the tree. What it does at the top here, there, it's saying get me all the legal moves. That's what it's saying. Get all the legal moves. So that's what it does here. Get me all the legal moves. And it's got 2 moves. It would say 2 moves. Then it will make 1 move. And then it would say, get me the legal moves again. And it will have 2 legal moves. And it will pick one of them. And it will make the move. Then it will say, get me the legal moves again. But what will stop it going further is this thing here, which is the depth limiter. It says if depth less than 0, return this evaluate win side. So it will return a number. So what it will do is when it gets here, it will hit that depth trigger, or even if there wasn't a depth trigger, what would happen is there'll be no moves left. So the move count will be 0 and it will do the same thing. Okay. So even if there wasn't a depth trigger, there'll come a point where there's no more moves to be made. And then at that point, it will get the score. But most of the times, this will do it. So it will go to the depth, hit that trigger, and then it will generate 4. Okay? Then it will think, just like the man who looked at the bag and says, first bag, he said, I've got 100. It will say, yeah, I've got 4 here. and yellow is the max. So it's got 4 there. So then you look at this one here. So what it will do is it will evaluate that, it'll come back, and it will try the next move, which is here. Can you see here? Loop all moves. And then it makes the move here, and then it takes it back there. So that's what it will do. It will take that back, then it will make this move here. And then it will say 4 was 6, and it will say now I've got a 6. Because it wants the maximum. Yellow is max. So them 2 scores there, that would become a 6. Okay. And then that tree is complete. So you come up here, and that's a 6 there. And then it will come down here, and it will get to here, the depth thing will hit it, and then it will get a 7 here. And this is what I wanted to show you. As soon as it gets this 7 here, right, it's there. Remember, yellow is the maximizer. So yellow has got a 7 there. However, red is the minimizer. So red is your enemy. So there's absolutely no way he's going to give you that 7. He's going to say, you're going to get this 6. He's got a choice whether to give you a 6. And you've got a 7 here. So it doesn't matter what this is. It doesn't really matter because he wants the minimum. Okay? So if that was a 10, it doesn't matter. Because he wants the minimum. He's here and he wants the minimum. So he will not give you that 10. So therefore, it's a waste of time looking at it. So what it is, if you go through this tree, you see you get cutoffs like this. And that is the cutoffs that alpha beta will do. And using this algorithm. Okay, so I'm going to show you some pseudocode. This is what we were using before. And this is Minimax. And this is alpha beta. As you can see, there's not much difference. There's not much difference. But for performance-wise, it's tremendous amounts of difference. Now, as you can see here, it's got the value here, and then it unmakes the move, then the value more than best. And here one, it's got if value more than alpha equals value. So what you can see there is best is replaced by alpha. Okay. So what I'm going to do is, the first thing I'm going to do with this, I'm going to copy it. Because as you can see, there's not much difference. So I can copy it. And then I can call it alpha beta. Okay. And as you can see, what's the first thing I'm going to do? It takes an alpha and beta parameter, so I just have to put them in. Okay. So we got a best score, which is this. So remember, the best score is going to get replaced, as you can see here. So I'm going to just get rid of that now, so that it will highlight it in yellow. I'm not going to delete it, but I'm going to do that in case I made a mistake. Now all this is going to be unchanged. All of this will be unchanged because this still stands. So as you can see, generate moves, make next move, and unmade move. So what we have to do is we just have to move the unmade move, which is here. So I'm going to get that, I'm going to cut that. And I'm going to put it under here. Okay. Now what I'm going to do is I'm going to add some code for this part here, because as you can see, that is just replacing best score with alpha. Okay, this one does something, then it returns. So I'm going to add the score. I'm going to add the code for beta. Okay, if we still need the best move, I'm going to use some of the same variables just to make it a bit easier for myself. Now this has got to return something, so we have to stick to, it's going to be similar to this. So what I'm going to do is I'm going to copy this and I'm going to change something on it. And I'll explain it when I've finished. It's gone into a mess. Sometimes that works. I think I'm going to select the whole method factor. Anyway, I don't like when this gets messy. Okay. Is score more than equal to beta? So this is, that's why I highlighted, that's why I took best score out, so that I can see clearly. Let's just separate that. Okay, just got to return beta here. Basically, so what this is doing is, when we scan all of these positions, we need the best. For alpha beta, obviously we need to get the score, but the score's not good to us to say, okay, this which move is it? We need to know the move. So when it gets to a player of 0, it needs to return the move back to us, not the score. When it's gone past a certain level, like here, if it went down to here, it might return scores. It returns score here, score. But here, that's the last place, and we want the move now, not the score. So that's what this code does. So even though that algorithm was saying something else, we still need the score. So that's done, apart from it looking messy. Shall I take a chance and fix it? No, it's not going to fix. Too much code there. Okay, I'll carry on. Oh, that would have to do. So that is the beta part done. I'm just looking for like drawing. There it is. That's the beta part done. Now the alpha is just replacing the best score. Okay, with alpha. Right. And this is doing the same thing. If the apply is 0, we need the best move. Okay. I think that is it. But one thing I'm going to do is, you remember we put this line in because we wanted the computer to fight to its last breath instead of when it's seen that it's lost. I'm going to have to take this out because this is for Minimax, and to get the same effect, it's gonna different for this, so it's not gonna be the same thing. Another thing I'm gonna have to do is change this. I forgot about this, but it wouldn't have worked, and I would have been sad. Okay, as you can see, I'm gonna have to put minus beta minus alpha. So it's minus beta minus I think that is it. So I'm going to have to go to computer move now and swap them over. What I'm going to do is I'm going to keep the old one. Just in case alpha beta keeps beating me, then I can start playing the old again. Now we've got to put some values in here. And if I get this wrong, it won't work. I think it's mine is going to be, then we'll have to get infinity. Let me just put infinity in here. I advise anyone to learn about this structure. Look how easy it is. So I'm going to put in minus infinity for alpha and infinity for beta. Okay, so now I'm going to test it. And I've got some test. I've got something to test it with, and that's our favorite game that we keep playing. Let me just make this bigger. So that's what the other one took. It took 5 seconds, 5 seconds. These are the moves. This one is going to make the exact same moves until it gets to here. Because we took that line out, it won't fight to the death. It will just, as soon as it sees that it can't win, it's just going to make a silly move and lose straight away instead of fighting. So let's see if it works. I'm going to open up the console because I want to see. Right. Okay. It didn't work because as you can see, that's taking the same amount of time. With I'm using the wrong. Am I using the wrong? I think I'm using the wrong computer move. So let's put that back to where it was. So infinity is not defined here, so I have to put it in there. So now let's give it a try. Yeah, and it worked. Now I'm going to play the exact same game. I'm going to compare the timings. Well, I think you can see the timings. Now, about soon it's going to just give up. See, he's giving up now because he's just thinking, I can't win. Okay, so what I want to do now is I'll show you the timings. And you see the massive difference. It's 100-fold. Look at the first move. As you can see, all the evaluation will be the same. And as you can see here, it's got best score. So it's lost. At this point, it's lost. So that's why it started playing silly. But as you can see, look at this one. It took 60 milliseconds for the first move and 60 milliseconds for the second, and 27, and this was taking 6 seconds, 6. So you can see the massive amount of time saved. Now what I'm going to do is let's have a game of it. Let's have another game of it. See what it does. So I can now set this to 12. I won't set it to more than that. It's going to be too slow. Right, let's see the timings now. So what this is now doing is it's doing the alpha beta. So it's cutting out so much positions that it is seen to double the length. In fact, I forgot to do a video and because I'm recording, it's going to mess up my video. Okay. So I think I've gone over the min-max. There's other optimizations I can make. In fact, I'll wait for this move to make and then I'll show you some other stuff to do with min-max and alpha beta. I'll give it another minute. It's made it to move. There you go. It went to a depth of, it took 91 seconds and went to a depth of 12 moves. And before, 8 is the max it could go to. Alright, I want to show you something. If I set it to a board of 5 by, let me set a small board. I'm going to play 3 in a line. So I'm going to show you what I mean by it's playing silly. It can't win this position. So watch what it's going to do. It's gone there, and I'm going to go here. And because it can't win, it hasn't bothered. Oh, I forgot to put reset. So I'm going to go there. I'm going to go here now. Because it can't win, it hasn't bothered to block that because it's thinking, I'm going to lose this position anyway. So it hasn't. And another thing as well, another funny behavior is this. In fact, what have I done? Let me reset that. Now, if I go here, wait there. Sometimes it doesn't take the win. So I can go like this, and I'll probably still win. So if I go here, okay. So that's enough for this video. Until next time, it's bye.